Good afternoon. I'm sorry. So good afternoon. Well, before I start, I want to ask you some questions. Have you ever felt in such a situation where you need more peaceful time and you need to calm down by yourself through all the sounds and the noise that you always hear? Well, yes. Have you ever felt in a situation where you could only wish for one day you could be at a mountain where there will be no voices or no noises from the town or the city or whatever? Have you ever felt in that way?
Yes!
Well, I'm going to tell you some stories. The first is, in my village, I live next to an industry. Well, this industry makes a lot of noise at night. I cannot make my homework well because I can't concentrate. And the second thing, I can't sleep well. That's obvious. And the second thing, when I went to my school, I saw a lot of bamboos. My school liked bamboo trees. And when they cut the old bamboos, they will create a lot of waste. And it also dirts the environment. In my opinion, it is a very, very wasteful thing to do. We can use this bamboo waste into another material which maybe could be used for our environment. And the third thing is plastic waste. Well, it's a common problem. Everybody knows that we are facing the overwhelming plastic problem. So through all these problems, I'm going to conclude them into one experiment, which is making the plastic bamboo composite to fight against the noise. The theme is At Peace with Waste. My name is Shannon Kanamara. I came from Santa Laurencia, Jakarta, and I'm one of the physics team. So the problem statement is to reduce the disturbance by using the bamboo and plastic wastes. Before that, I will also explain the advantages and disadvantages of the materials which is composing this plastic bamboo composite. The advantages are, first, there are abundant resources. We can find these bamboos everywhere. And in this experiment, I'm going to use Gigantocloa apus, or maybe you will hear it, rope bamboo. Flexible. It's the second advantage which bamboo has. And the disadvantages are, first, they're easily broken by humidity and termites. And the second is by limited geometry, which is a cylindrical shape. Before it can be used as a building material, it has to be cut it down and it will create a lot of waste. While for the plastic, the advantages are, first, they are ductile and elastic. Everybody knows plastic, right? Yes, of course. We saw plastic every day in our life. And the second is they are strong against weather. And the third, they're easy to be formed. Yet the disadvantages are, first, they are hard to degrade because they took a long of time to let themselves degrade on the environment. And if we want to reduce the amount of plastic waste, we have to burn it down. Well, it's a common thing that people usually do. But this also creates another problem because the plastic that is burned will create dioxin gas, which is very poisonous if we breathe it in. So the research methodology is, first, we have to prepare the materials, which in this experiment, I'm going to use polypropylene plastic, like this. And we're going to use crushed bamboo with its species is Gigantocloa apus, and then we make it into a PBC, or we call it plastic bamboo composite. And then I'm going to test it in a sound absorbing and mechanical test. Then we get the data and analyze it, and we can take in the conclusion. On the theory statement, sound baffle is the name of a material which could reduce sound. Well, a sound barrier is a sound reducer material that reduces the amplitude, or how strong and weak the sound is, and the frequency of it. While the thing that I want you all to know is soundproof and sound absorber is a thing which is very different from each other. So before I'm going to tell you the result, this is the thing that I made to test my plastic bamboo composite. Actually, I had made my plastic bamboo composite into the real one like this, but due to the lack of time, I haven't cut it down, so I'm going to use my last plastic bamboo composite, which is in a sandwich mode. Then I'm going to put it into this thing, which the testing box. Which will then I will use a spectral lab software where I will test this plastic bamboo composite. Well, the first procedure to test is to let the plastic bamboo composite out first, and we will see the frequency wave in here. So here it goes. So then we will save this so we can test it another time. So in this graph, we can see that there are some decreasing in the graph, especially in the frequency from 300 until 20,000 hertz. 20 from 20,000 hertz is audiosonic, where the humans can hear the sound. So this material is applicable as a sound barrier material. So in this graph, we can see in the simple graph I have just concluded that this without barrier, the graph is slightly higher than with while we test it with the barrier. Unfortunately, I haven't made the mechanical test yet, but it will come soon. So the conclusion is my plastic bamboo composite is able to become a sound barrier, just like I said before. And the future work is, with this material, I'm going to try applying it on small industries and homes to produce, which produce such frequencies. And again, I will test and identify the plastic bamboo composite so I can classify it either in a sound absorber or a soundproof. Again, let's fight noise with waste. Thank you.